So what are some good characteristics of technology-based mathematics tasks?
Um, and a very important part of any good mathematics task is that it's open and allows opportunities for multiple routes to the solution. So by having an open task, you can have students enter in at whatever cognitive level they're at, and then build from that place to more complex examples of that use. So for example, even in early grades, if you have students that are doing mathematics tasks and you, um, uh, rather than asking for a solution, you ask for what are possible solutions.
Nice.
There are some really nice apps that are using tools that are conceptually building, like 5 frames and 10 frames and things like that, or coin apps. But if they allow students to be able to ask a question like, instead of I gave you $1 and it was 67 cents, what's my change? You could say, this is what these things cost. What are the possible coins that could be in my pocket, or what possible coins could they give back? So there's not just one numeric solution, but lots of different ways of putting together that solution to show understanding. The strength of the technology is that you can capture the range of thinking that students are engaged in, and really build and open up that thinking.
I think ones that, and I'm thinking of particular kinds of math technology now, is ones that really have some dynamic feature to them. So if there are tasks that take advantage of that feature in particular, because that's something we really can't do with paper and pencil, is have students dynamically explore some mathematical phenomena. I think if there's a task that's really tapping into that, those are particularly powerful. And they are ones that are taking advantages of affordances that technology is providing that nothing else can.
This is a work problem applet that I've created. And in this case, you have 2 people who can paint a wall. One paints the wall in 3 hours, a second one paints the wall in 5. And the reorganization is this linked representation where instead of just representing it algebraic, just representing the amount of wall painted as a function of time, using the algebraic expression, we also come up with the linear expression. And so the idea of painting together becomes adding up the 2 mathematical functions there. And I think that's really powerful for students to reorganize the way they think about the mathematics.
I also try to avoid things that are going to maybe be misleading. Maybe they'll find a result that seems like it's always going to be this way, and it's actually not. And so I want to find something that if it does do that, they can kind of have that discussion at the end. So whether the technology is maybe an introduction, but it leads to the sort of end of class whole conversation where they can discuss their findings and avoid that misconception.